Hello, everybody. Thank you for joining us for Stirring Student Ideas, Instructional Moves to Support Motivation in Math Class with Kristen Gray. We are so excited to have all of you here. I'm going to give everybody just a couple minutes to join. So while we prepare for that, go ahead and drop in the chat. What's your name? Where are you from? What's your role in education? We'd love to hear from you. I will drop my information in as well. Hi, Amanda. Oh, Amanda, we're neighbors. That's always exciting. Long Island, very cool. Richmond. Island Springs sounds like a getaway, like high school location. I love that. Iowa, so many fun locations. SoCal, jealous right now. People from all over the place. Trish in Chicago, if you are going to be at NCTN, make sure you stop by and say hello. I will be there. Hi, San Diego. Do we have anybody? Oh, I was just going to ask if anybody's international, but we have Brazil and Ontario. Very cool. Is anyone from Indiana? The UK? Also jealous of the UK. Okay, I'm going to go ahead and get us started. So again, thank you so much for joining us for Stirring Student Ideas, Instructional Moves to Support Motivation in Math Class. My name is Ryan and I'm here from Amplify. I'm just going to get us started on a few quick tips for how to engage in this webinar before I pass things over to our incredible speaker, Kristen. So with that being said, if you would like to use closed captioning, please feel free to go ahead and click that CC button in the bottom tray of your Zoom. That will give you the option to include subtitles for this webinar. So please make sure you do that if that's something you're interested in. To participate in this webinar, we would love your participation. I know Kristen always enjoys hearing what you all have to say in the chat. Please feel free to leave those comments in the chat. But if you do have a question that you would like Kristen to address at the end of the webinar, make sure you use the Q&A function in the bottom tray of your Zoom. When we have time, at the end of the webinar, we'll go over some of those Q&A questions. So if you have a question you want Kristen to answer, please drop that in the Q&A. You will receive a certificate of attendance for this webinar. So check out an email from Zoom for over the next couple of days to make sure that you get that certificate. But that's all from me. So with that being said, I'm going to go ahead and pass things over to Kristen. Kristen, thanks so much for joining us.
Thank you so much, Ryan. I'm going to share my slides and go into presentation mode. All right, Ryan, thumbs up. We can see screen okay. All right. Thank you everyone for coming. I know it is just back to school time. I have gotten back into school, so it is nice to have you here, and I appreciate you taking the time to be here with us today. So like Ryan said, we're going to talk about stirring student ideas. I always like to, we talk about motivation, but I also want to make sure that we also have instructional moves to support learning. So we'll be supporting learning, but also supporting motivation and such. Again, like Ryan said, I work across the math suite at Amplify. A quick little blip about me. I am from Lewis, Delaware, so just the south part of the state of Delaware. I taught and coached around here for 22 years, did some work with the teaching channel during that time, then went to illustrative mathematics, headed up their 6-8 professional learning, and then moved into heading up the K-5 curriculum and professional learning at illustrative mathematics. Once the curriculum wrapped up, went to Amplify, and now I'm just working across the math suite on the different components of our math curriculum. And the interesting part of my job, which makes me so excited to talk about stirring student ideas because it is such a part of my weekly work, is 2 days a week I'm in a local school where I coach and I teach, and we do learning labs together, which I'll describe at the end of this webinar in just a quick little summary. And through all of that work, just always obsessed with student thinking. So I tried to capture a couple pictures there. That's the thing that drives the curiosity I have around teaching and learning. So I'm excited to share that with you today. So today, just I like to frame it with a few questions. We're going to talk through what does it mean to stir student ideas in math class? Why is it important? And probably the crux of the whole presentation is what are some instructional routines to help stir these student ideas? So hoping that you'd be able to take some of these ideas and use them right away tomorrow in your classroom. And since we're going to be talking math, I thought it only right to start with a math problem. So Aunt Ida has a vegetable garden and flower garden, and she wants to use what comes from these gardens for her parties. The vegetable garden is 6 yards by 5 1/4 yards. The flower garden is 5 yards by 6 1/4 yards. And what I would love to see in the chat is I would love for you to pose a math problem that you could answer based on this information. So just take a minute, and if you think of more than one, feel free to put them in there in the chat. What problems could you answer based on the information on the screen? Great. Which is larger? Which, Stacy, that would be interesting to say, how do we determine larger? What does larger mean in this scenario? What's the ratio between the veggie garden and flower garden? Area of each garden? Oh, area of both of them together. So we go from maybe a one-step to a multi-step problem. Love it. Combined perimeter. Nice. Amount of fencing. Good. Building on that perimeter. If we keep it in context, we could talk about fencing. Oh, is our garden large enough? How many tomatoes could you plant? Difference in the areas. Difference in area and perimeter. Yes. Oh, these are so good. We might also see when we do, this is what's called problem posing, which I use a lot in the classroom. It's a really low lift, high leverage instructional move by just stripping away the question part of it, the situation, and posing a situation, asking students what math problems could you answer based on this information. It kind of takes the notice wonder routine, but zooms it into really specific math problems about this, and students love it. Um, so I appreciate all of you, and these are great. We might even see some students ask questions like, how many gardens does Aunt Ida have? What are the side lengths of the veggie garden? What are the side lengths of the flower garden? So you might even see some questions that are more interpreting or like just pulling out the numbers and units of those numbers and meaning and making questions around them. And then we'll see a lot like we're seeing in the chat in terms of the area and the perimeter. And it just elicits so much great language in the classroom. And now I'm going to set those questions just to the side for a second. Thank you all who are in there still putting questions. If more come to you, please, like Ryan said, I love the chat being active, so it feels like I'm not here by myself. Please feel free to keep dumping them in there. But what I would love for you to think about is if I asked you, and I think something like this question came up in the chat or some variation of it, the question that goes along with this situation is which garden has the greater area? And I don't want the solution in the chat. What I would love in the chat is what would your strategy or approach be to starting this problem? So if you were to take this information and start to answer the problem, which garden has the greater area, what would you do? What would be your approach to this particular problem? And if you could put that in the chat, and then I encourage you to see if somebody mentions an idea that you hadn't thought about. And I would like you to get specific. So if you're finding the area by multiplying, how would you go about multiplying? If you were drawing a picture or a diagram, what would it look like? What would you attend to? How might you label it? So try using some of the numbers. Oh, great. There's one, Kristen. Multiplying using improper fractions. Grid paper to draw them one on top of another. area models. I see the mixed number to improper. And as you're reading other people's responses, try to think about if you're taking away an idea you hadn't thought about before. Good, converting to decimals. I see some partial products in there using the distributive property. Oh, then somebody mentions distributive property. Oh, other people rephrasing the problem. What is more, 1/4 of 6 or 1/4 of 5? These are so good. So what we're doing right now, and if we were in the classroom, I might have had these ideas listed and we would be talking through them. Um, but the whole point of this, of asking you to pose problems and to share what your first step might be, is to stir the ideas of the group that we have here today, which is what we want to do in classrooms. We want to stir the ideas of the students in the classroom. And these are just two quick ways that we can do it. We can strip away the question, ask them to pose problems. That's stirring the ideas of the concept, the context, making sense of the context, and bringing in all of our prior understandings about what we can answer based on this information. And then when we get down to the question, this idea of how would you approach it just from the very start? Like, for example, I hadn't thought about the thing I liked. I hadn't thought about drawing them over top of one another and what that might look like. And that's an idea that I'd be really interested in figuring out. And so for people who might jump right to multiplication, having these other ideas of how we might visualize it, how we might represent it, how we might use numbers other than fractions and go to decimals. All of this is what we call stirring the ideas of the students. Phil Darrow said a quote one time that just sticks in the back of my head whenever I'm teaching. He goes, when they're problem solving, the goal is to stir the ideas of some into the thinking of many. And I keep that tucked in my head every time that I'm doing problem solving and I'm walking around and seeing different strategies as the teacher. But I want students to see those strategies. And I'm constantly thinking about how can I stir these ideas? Just like that quick Phil Darrow. Phil Darrow was one of the authors of the Common Core State Standards. So we worked together on these instructional cards that I'll show a little bit later on. And one of the things he continually says is, how can we stir these ideas into the thinking of many of the students? And so it's important to do that because we want students to develop strategic competence in learning. And what that means is students understand, what does it mean to learn, and what they are, who they are as learners, how they go about their actual learning process. How do I plan, monitor the way that I'm thinking, revise, and reflect? And that's really important. And sometimes students think, oh goodness, if I start class and I don't know it, then I'm just not good at this. I might never know it. And the part of learning is acknowledging that learning is actually taking in all these other ideas and coming out with a different way of thinking at the end of class. And we want students to have that experience. No, it's definitely not one person. I just didn't list the whole thing. How People Learn is a compilation of a bunch of authors, Shelby. Yes. So I just put the paper there, the book there. So people had the title if they wanted to go and look it up. And then I love this idea. I'll call it stirring ideas. Tracy Zager, a good friend of mine, wrote a book called Becoming the Math Teacher You Wish You'd Had. She calls it cross-pollinating ideas. And I really love that. It creates such a visual in my mind as well. And her purposes for it, aside from that strategic competence that we'll see in just learning in general, really specific, she'll talk about mathematics, about exposing students to each other's thinking. And the second bullet is one that really sticks with me, about giving them time and opportunities to react and engage and build on those ideas for themselves. I think a lot of times when we think about sharing ideas, which could be interpreted as stirring ideas, it's at the end. It's at the end of an activity, at the end of a lesson. And that's important also. So I don't want to downplay that timing of connecting, making connections between one another's ideas. But if we really want to give students time and opportunities to react and engage with others' ideas and build on those ideas, we can't wait until everybody has the solution, or we're at the end of the activity, or we're at the end of the lesson. So in this webinar, we'll be talking a lot about the different points and times not at the end of the lesson. So we're going to assume the end of a lesson is a synthesis where students' ideas are being connected, but we're going to be talking primarily about how do we stir the ideas during the entire class, period. And that starts at the very start of a lesson. So I'm sure that we've all experienced, we have a lesson that is starting. We know at the end of the lesson, we are moving toward a particular learning goal. But to start that lesson, if we started it right where that lesson starts in terms of entry, we might have students at all different places. And this is just a subset of 5. We have 25 to 30 students in a class. It's going to be even more varied. And so what we don't want to do is we don't want to start that lesson ignoring what every student is bringing to that particular lesson. And if we do just start it and try to keep pushing students toward that learning goal without acknowledging and building what they're bringing to that lesson, then we haven't stirred the ideas of the classroom. So instead of just starting, and if we tried to start where each individual student is, it becomes even more challenging. So if we think about a 5th grade math lesson where they're adding fractions with unlike denominators, we might have students who have done that already. We have some students who might be really fluent in generating equivalent fractions, but might still have a little maybe challenged with adding like units, or vice versa. We might have students who can add fractions with like units, but haven't generalized equivalence yet. They're just not at that point of generalization. They might be drawing pictures to do it. So none of this means students can or can't. It just means what students have been exposed to, what they've learned up to this point, and what they're bringing to it. So if we take away that really stark lesson start and instead stir these ideas, start with a problem, and have students sharing and engaging in one another's ideas, now we have the rest of the lesson to move toward that learning goal. So what I might do in that 5th grade lesson is I might just start the lesson by putting a problem up and asking students to solve something like 3/4 plus 7/8. And we might see some students drawing diagrams and partitioning to find equivalents and combine them. We might see some students generalized multiplying numerator and denominator by the same number to get an equivalent fraction. And those students now are talking to one another and seeing one another's work. And now we've stirred the ideas. We've acknowledged all of the prior understandings and experiences students are bringing to this math lesson. And we're stirring the ideas to start to move collectively toward that learning goal. And Ryan, I'm trying to not, I am the worst at notifications. If you look at my phone, I will never see a red dot. It will be taken care of like that. So please, Ryan, if there's something in the chat, please come off mute and just stop me, and I will definitely look that way. So that's at the start of the lesson. So we can stir student ideas right from the start to pull on all of their prior understandings and experiences. And then if we think about the middle of a lesson, I think what we typically see happen is if students are in groups, and let's say we just have student A, B, and C, I just put those wherever. We can imagine that A and B talk to each other a lot because teachers will do a really quick turn and talk to your partner, work with your neighbor. And so A and B start to work together a lot, but they never might hear the ideas of C until the problem is solved. And vice versa. C might never hear what student A had been saying and what student B had been saying. And if they sit together a lot, they might start to have really similar ideas. So the variety of A and B over time might not be varied. And the same thing happens if you're arranged like this. This pair of A and B might never hear what that C says, and vice versa. So stirring ideas in the middle of the lesson is really important, just to pull on all of the knowledge and experience and expertise that's in the classroom. And the same thing happens not even at the student level, but at the group level. I know a lot of time we'll work in small groups. So small group 1, do they ever engage with the ideas of small group 2 or 3 or 4 or 5 or anybody else in the room? Or are those 4 the one? That's the limited set of ideas that they're having in the classroom. And the same thing in the other setting. We might have group 1 and group 2 never share ideas with one another until the end, until the solution is found. And now we're sharing and connecting strategies, which again, very important, but we want to have some stirring of ideas for learning before we get to that particular point. So We're going to start talking now about instructional routines that help stir students' ideas. And I'm sure some will be very familiar, and there might be a couple that are newer. The first one, oh, but let me start with this first. The cards that I mentioned at the beginning. Phil, Darrow, and I, who I talked about before, he and I worked on a set of instructional cards that Ryan will be sharing at the end of the webinar. And we took questions from our own teaching and coaching when we work with teachers that came up all the time, even in the best planned lesson. There's these questions that always come up because classrooms are just such dynamic spaces, such as how do I get students all participating in whole group discussions, small group discussions? What do I do when progress is varied as students move along? How do I balance problem solving? And on these cards, on the back of these cards, we came up with just different instructional moves. 4 of them really apply to stirring student ideas. And on the back of the card, you'll see a reference to one of these routines. And so these 4 cards, whole group discussion, small group work, progress on an activity is varied. And what do I do when students struggle to get started on a problem? They're just not getting into it. What do I do then? So on the cards, like I mentioned, we're going to have an instructional move. And sometimes that move will be something that stirs the ideas. It'll be an instructional like routine that you can do with some questions afterwards. So I use those cards as just the basis of some of the routines. And one of the routines is from the Amplify Desmos Math curriculum as well. But we're going to go through some of those routines. So when you see them on the back of the cards, you'll have more of a context for them. This one I'm sure is very, very familiar. It's called a turn and talk or a think, pair, share. The way it works is students are provided with a short prompt to discuss. They turn to their partner and answer the prompt. Their partner listens, and then they switch roles, and the second student addresses the prompt while the first partner listens. Again, this is more that A-B talk that happens a lot. We want to make sure that giving a really good prompt. So for example, we might ask them to turn and talk about what does your work show about the problem? I know sometimes, I'm guilty of it all the time. Turn and talk to your partner about problem 1. If we're not specific, then what they're talking about, problem 1, might not be the thing that we want to connect and make explicit toward the end of the activity. So having a prompt that really drives their discussion and is grounded in the work that they're doing. So it's not just talking up here, it's actually looking at one another's work and making sense of it, is really, really helpful. Oh my gosh. So keys to success. We also have these on the back of the cards. We'll put little tips of keys to success. This will be a little bit more built out because the cards are only so big. But ground the discussion by giving specific prompts. What does your work show about the problem? What are you drawing or writing to help you see what's happening in the problem? For example, if we go back to the very first problem that we launched with today, I might ask you, what does your work show about the problem? And those of you who were multiplying, you would have to explain how, for example, that distributive property, if I had 6 times 5, 6 times 1/4 or 25 hundredths, where do you see that in the problem? How is your work represented? That way, the students who's drawing a rectangle and finding the area on a gridded rectangle, how is that related? And now how are these two related? So making it really concrete about the student's work and specific helps the turn and talk and think, pair, share be much more productive. Change partners frequently. Again, A and B, those 2 students in that image, if they talk to each other and we're not switching seats a ton, the variation of ideas might be pretty narrow. So we want to make sure that we change partners frequently. Keep the timing to 2 to 3 minutes. We know that sometimes the longer we go, the more maybe off course the conversation goes from the math. Follow with a whole group discussion. And the whole group discussion afterwards, it's sometimes or often it's about the answer to the problem, but we also want to make sure that that whole group discussion is the process that they just went through. So it incorporates that particular process about the prompt. Again, really trying to support students in thinking about their own understanding, how we come to learn something themselves as a learner, what it means to revise and reflect. So we want to make sure that we don't just reflect on what did you and your partner talk about? Did you get to the answer? We want to make sure we're reflecting on, did you agree or disagree with what your partner had shared? Can you give an example of what your partner had said? Or maybe something like, did something your partner say change the way that you're thinking? Or you're going to use that to finish out the problem? So just being really specific and also just toggling between focusing on the particular approach and answer and the metacognitive. How do we work together? How do we learn together is really important. So that's going to be really powerful in like bolstering up your turn and talks and think, pair, shares. If you're familiar with complex instruction, long ago, you might be familiar with the role of the spy. Again, Tracy calls it a cross-pollinator group role, which I think is a lovely term. But this is one way to bring ideas back to your group from around the room without having the whole room up and going. So the way this works is in every small group, one person is assigned the role of, you could come up with whatever name works for your classroom. Complex instruction uses spy, cross-pollinator again was Tracy's. You might think of something else clever that works. But each small group has a person assigned to that role, and you can leave your group when you're problem solving together one time. That student circulates the room and visits other groups. They're not having conversations, they're simply listening to what other groups are talking about. So the other groups, everybody's group keeps on moving while that person is going around the room. And then the goal is to gather new ideas, approaches, questions, and strategies to bring them back to their group. So this is a really nice way to get ideas from around the room stirred up back to your group. We just did this in the spring of last year. Third grade students had just started their formal work with division. And so I always launch with, if you don't have dozens of donuts and you're in third grade with division, it's the best launch to a division unit or chapter, whatever your curriculum uses. But we read Dozens of Donuts, and the context of Dozens of, and Luann, that bear, is making donuts, and she keeps having more and more visitors show up, which means they're getting less and less donuts on their plate. And so what we asked them after we read the book, Did a Notice Wonder, asked them to go back on their boards and as a group, represent all the different ways Luann shared her dozen of donuts. So sometimes she had one guest, sometimes she had two guests, sometimes she had three guests, so on and so forth. So what happened is students, a group really fixated on one particular representation is what we noticed as Katie, the classroom teacher, and I walked around. So this particular group was really focused on the drawings. They drew the plates, they look like cookies, but maybe they were donuts. And then after their group spy walked around, they came back and they started adding multiplication and division equations that matched. You can see that 4 times 3 equals 12 matches their picture at the top. So that was an idea they brought back. This was the only group that I actually caught the beginning and end. The rest of it just, once class starts going, conversations go crazy. But you can start to see how students had various representations. So this group started with the 2 groups of 6, the words and the drawings of each of the plates with the numbers. So it's just a little bit more abstract than the actual donuts. Now we're seeing the numbers are on each plate versus the actual discrete drawing of the donut, which is really nice. And then as they went around, now we've got multiplication equations that match what they are thinking. This group, again, you can see multiple representations of the division, the multiplication, the drawings. And then I just think about the cross-pollinating idea and a student group who is thinking all multiplicatively, which is wonderful, but they go to this and they're starting to see the commutative property, they're starting to see the division equations all in this set, which I don't know if they call them a fact family, whatever they might call them, but they put them together. And I thought that was just really unique when we think about students walking around and if they had been drawing these. So 2 times 6 to them was 2 groups of 6, 2 plates of 6 donuts. And they get over here and you'll start to see 4 times 3 equals 12, 3 times 4 equals 12. And then picking which one matched the image, it just is really, I think it's so fascinating and interesting. And I just love the idea that kids can walk around and see all of these ideas and bring them back. And it's not the reason spy doesn't resonate with me is it's a little bit sounds sneaky or like you're trying to hide something, where we think ideas should be out there. So cross-pollinating might be the word, but all of this incorporates whatever the name of the role is all stirring the ideas of what's happening in the classroom. And then Katie and I really appreciated that when we looked at their exit tickets, you started to see the various representations showing up on the exit tickets, which I thought was really, really nice. So it something in there stuck with them because we didn't ask them to solve it in multiple ways. We just said, solve each problem. And they just got into the habit of, oh, here's the different ways we can think about this. And this one, I get when I go back to that commutative property poster, I think about this one where they showed both versions of the factors, but then starred the one that matched the actual question the question being asked, which I thought was really nice. So just this stirring of ideas, and in particular, gallery walks are a really nice time to do that. Because gallery walks, I don't know about you, but gallery walks for me are always tough. Even when I give them a question to like something to look for in the other posters, it's just really hard to navigate. So this was actually a gallery type lesson, but we structured it just a little bit differently and asking the one person from each group to go around and gather an idea or something different that they hadn't thought about in their group and bring it back, which worked beautifully. Just a couple things, keys to success. Until students are familiar, you might want to announce when the time starts. Toward the end of using this routine, you just tell the students, okay, you have the one person in your group who can go around to another group and gather ideas whenever your group is feeling the need to, when they're ready for it. That helps them to determine, like, when do we want to see the ideas of others? But if students are new to it, we don't want all the other groups to get finished, and that's when everybody's going around, because we want to do it while curiosity is still buzzing in the classroom. So you might want to announce maybe a minute or two after they've gotten into the problem, then announce it. So you might just want to get them acclimated to the timing of it. Again, be sure it's before the problem is solved. If it's helpful, I've had some students who have to keep going back and forth to the group because they're like, oh, wait, I forgot. How did they write that? So it might just be helpful. Some of them carry a little tiny whiteboard around with them if they see an idea they want to bring back, or a notebook or something. So you just want to make sure that it's accessible activity and it's not creating a bunch of extra running back and forth in the classroom that might be distracting to some groups. So that might be helpful. Again, purpose for ideas being gathered. With the dozens of donuts, we asked them to find an idea that their group hadn't thought about yet, but connect it back to what they were working on. So that was our purpose. And it could be anything. Idea that helps your group think through the rest of the problem, changes the way that your group might be approaching it. This is a really great one, especially if a group is a little bit stuck on a problem. So for example, that area problem to start the webinar that we did, if a group was stuck getting into it, or they got so far and then they collectively as a group got stuck, it's a nice way for them to go somewhere like, oh, I saw them multiplying using improper fractions. Maybe that's something we want to try. And so it might change the course of their particular work as a small group, which is really, really nice. The walkabout, this is one. Now, this one's going to be much more movement. And I didn't put I started putting all of the students, A, B, C, and lettering them all, and all of the arrows, and you couldn't even tell what I was trying to do. So I just did one table. But the way a walkabout works is students leave their work on their desk. So students have gotten started on the work. You tell them they're going to do a walkabout. They leave their work on their desk, and they're going to walk around to others' desks to see the work that they've done. They get new ideas, and then they return to their work and they finish out their problem, hopefully incorporating some of the ideas that they saw. So this is not only is it nice for leveraging others' ideas to revise and finish out my work, but it's also really nice. I've seen students take a lot of care in making sure that their ideas are clearly communicated in their work. I know anybody who has taught, when you look at student work, sometimes figuring out how they've organized their thinking or not organized their thinking so well. And I'm one of them. I'm guilty of it. If somebody looked at some of my math work, it might be like, what is she trying to do? But I've seen students take a lot of care in knowing that others are going to be walking about to be clear in their work. which I think is really nice. I've even seen students actually write a little question, something they're wondering because they know that um, people are coming around to their table. And I really, really liked that too. So it was nice. It was like, I'm stuck here or I wonder why. And they'll leave a little question on theirs, it's just a nice way of communicating and others coming around. And I think that's really great. And Shelby, I'm sorry, I just saw you. How do you encourage the group to continue problem solving? They just continue working. The first time it'll be a little bit distracting. I mean, like with anything that you learn, the first time is a little bumpy. So they're kind of watching the people walk around the room. But after a while, when you just say, all right, spy, go do your thing, and they're walking around the room, and the rest of the group keep working, they continue to work because they're trying to get through the problem as well. So um, I think it wasn't a problem. It definitely is something, though. It's going to evolve. It's going to be a little bumpy the first time, like anything. So keys to success with a walkabout, make sure, and I always do a quick monitor before I do any walkabouts, but I always make sure that students have some work on their paper. We don't, and they want to have some work on their paper as well because people are walking around to see it. Um, Again, it's the same. I mean, all of these will have the very familiar, do it while curiosity is alive. Don't do it once everybody has finished the problem, they're not really curious about one another's ideas. It's much more interesting for them when they're in the middle of their thinking. It's going back to Tracy's point of being able to use or leverage or build on someone else's thinking. That doesn't happen once the problem's solved. So you just always want to keep a pulse check on where everybody is in the classroom to get your timing. And so kids don't get startled, I usually tell them I'm going to stop you before you finish, just to let them know that it's no surprise that I'm going to say, all right, we're going to do a walkabout. And I don't want anybody feeling nervous that I've stopped them and they're not finished yet. So I always tell them, just to make it crystal clear with everybody, I'm going to stop you before you have finished your problem. Don't be startled, just leave your paper, walk around. Your goal is to look for ideas that you can come back and use to finish out your problem. And again, I always encourage them to use or expand, keep timing short. Again, anytime it gets to be too long, the wandering around the classroom isn't as productive. And then the same thing as I believe I had it on the turn and talk or think, pair, share slide. After the problem's solved, we don't just want to reflect on the solution and a couple strategies. We want to also make sure that we balance talking about what you learned from others' ideas. And again, that's just woven into a student's explanation. And after a while, students, it's like the talk moves. Once students get used to saying that second sentence, then they typically add right on. So I got 32 square feet for my area. And I used an idea from Ryan, who I saw him doing XYZ. So they get used to that second or third sentence reflecting on what they learned from someone else's idea, which is really nice, especially for other students. How great that you used an idea I had on my paper. That's wonderful. So that just like synthesizing that, not just about the answer and more on the process, I think is really important to keep in mind. The final one is in the Amplify Desmos Math curriculum. It's called Mix and Mingle. Mix and Mingle is where you display a problem, prompt, or cards, and I'll explain that on the next slide, with a piece of information. Students circulate around the room. They pair up with a peer, discuss the prompt, and then the teacher signals when the round is in it, and then you find a new partner, and you're going to discuss it with them, and then the teacher might signal again, and you find a new partner, on like that. And then you repeat as many times as you can. For example, in second grade, a mix and mingle might be something where every student gets one of these cards. It might be the cards that are in expanded, the numbers written in expanded form, it might be written in words, or it might just be written as the numeral. And they go around and they pair up with a partner. They use these sentence frames from the math language routines, math language routine 8, that discussion support. The number represented on my card is whatever the number is. I know this because And then their partner does the same exact thing. Then they switch cards. So you don't have the same card every time repeating what you said. Now you take your partner's card, you go meet with somebody else who has a different card, you do the same routine, you get the signal, you take their card, you go to another person. So it keeps it changing always, where you're not, if I had that very first card and I'm like, I know it is 641 because it's 6 in the hundreds place, 4 in the tens place. And then I go to the next person, I say that it stops that repetitiveness of saying the same exact thing every time. So you trade, and now you've got a new one to say as you go to the next one. If we looked in kindergarten, instead of having cards, we might do something where each kindergartner has a stack of the different colored cube towers. So I might have the 3 orange, Ryan might have the 4 blue, and we partner up and we have in our student edition where they're actually putting in the number. So I have 3 cubes, my partner has 4 cubes, we have 7 cubes all together. Then they take their tower and they find another partner and they do the same exact thing. So it's practicing that addition, but with the connecting cubes. And you repeat it a few times. So again, the mix and mingle can be something where it's a set of cards discussing those, or it can be an actual page where with a physical object or prompt that they are going around and discussing. This one's a lot of movement. It's a lot of pairing. Anybody that's done the math language routine Stronger and Clearer, where you pair, the students pair up, they share, and then they pair up with someone else. It's kind of like that same structure. Keys to success with this: always want to be crystal clear with students about the purpose. Why are we doing this? What are you going to be learning from it? And the timing of it. Consider using a cue. Oh, should have had a space there. A cue to, it said like music, and I deleted the like music, and there it sits. But anyway, a cue like music, when they should stop circulating. I'm always the worst about preparing for that. I end up having to yell over them while they're talking. But a cue saying I'm going to use the music or ring the bell, I think that is a great thing to do. Sentence frames, having them up is really, really supportive for students, and it keeps the conversation focused. And then the first time, as with anything, we want to make sure that we're supporting students in getting into the structure of the activity. And then after those first few times, they've got it. You can say, oh, we're going to do a mix and mingle, and they know what the routine is. That's the power of routines. But for the first time, you might want to pair up, like plan who's paired up together, at least to start. So it's not them all finding their first partner and then finding their next partners and such. And then you might want to model it with a student. So you play one of the students and you go up and you just model it so that they have a picture in their mind, especially if it's a new routine, of how it goes. That way, if we get the structure stuff out of the way, then they can focus on the math, which that's nice. And that's all we want to do here. I would be remiss if I didn't talk about stirring teachers' ideas for teacher learning as well. Again, I said that I work in a local school a couple days a week where we do learning labs. That is where a classroom teacher works with a coach. So I will sit and I will plan with a teacher. We go in, we co-facilitate it together. We look at student work afterwards, and then we debrief the lesson. It's not a new idea. This work has been done at University of Washington. Elham Kazemi does amazing research, and I know there's a few others on her team as well. So, but collectively, they've done a lot of work with math labs and college students getting into classrooms and doing this work of coaching and observing and reflecting on student thinking, which is really, really powerful. So in the most basic sense, we plan together, we teach and co-teach together. We usually will explicitly say, I'll teach the warm-up and then you take activity 1. So we at least know who is leading it, so it's not in the moment trying to figure out who's going to do what. We'll do that during our planning time. But we definitely do, Elham would call them teacher timeouts, where we will pause instruction, ask a question to each other. Sometimes it might change the course of the way that the activity is playing out, which is really, really nice. And it shows the students that we're learning as well, which is really a bonus. And then we'll reflect on it. So reflecting on the student thinking, what did they do? What could we have done differently if we had to do this lesson again, and such. What I love to do at the end of every session is just a really quick, or every webinar is a really quick connect, extend, and challenge. But we can take questions first, Ryan, if you think that is good. And if you don't have questions, you can drop in the chat. What ideas in the webinar connected to what you already knew? What were some ideas that extended your thinking in new ways? And which one is, or what is now a challenge for you to take and try in your classroom? And then Ryan, I will stop there, see if there are any questions. And if not, if you just want to take some time in the chat to say what connected, extended, or challenged your thinking, that would be great.
Well, so far we only have a clarifying question about the SPY activity that you shared.
Mhm.
Someone would like to know, during that activity, is the SPY allowed to interact with the other groups in ways like asking clarifying questions to them?
Yeah, this will be, I would say it depends on your class sometimes. Sometimes I'll have them go around and tell them that they can't. They just have to observe. They can stand and listen to the group talking and they can look at the work that they're writing. If there is a clarifying question, as long as it's not taking that group off on a tangent, I'm fine. Like, what does that 5 mean right there? Oh, it's area. It's the area, whatever. So I don't mind the talking. I know that the clarifying questions can derail a group's work, and I don't want that to happen. The thing I just try to be upfront with students is we're going to try this, and you can go around. If there's a really quick question you need to understand what they've done there, ask them. But at the end, we're going to talk about if that was distracting or not, and we'll change how we do it the next time. So I just try to be open with the students, especially the first time that we're doing it, is that we're learning what this routine looks like for us and how it works for us. And then we move on from there. Oh, thank you, Kim, about the routine cards. I really, really had a ton of fun writing them and trying to figure out like what are those quick moves because everything you got to be so flexible in teaching, and so just having those quick back pocket ideas of what to do in a moment where the same two students are raising their hand and talking in the whole group discussion, like what do I do? And I think hopefully it's a valuable resource. Oh, thank you, Denise. I love that. Shelby, I'm not sure about online instruction. On the last slide, I have if you could, I just need time to think about it, and then I would love to get back to you. There's my email address, Shelby. If you could email me that question, I will definitely think about it. I can't, that's not a question I can do on the spot, but I would love to think more about it. So please email that to me. These are just a few books also that I think are really valuable when thinking about cross-pollinating or stirring student ideas in the classroom. And so I just wanted to put them up there. If you haven't seen them, they're exceptionally valuable in teaching.
Hey, it doesn't look like we have any additional questions. So, Kristen, I'd love to share a few more resources if that's okay with you.
Yeah, that's great. Do you want me to stop sharing my screen?
Yeah, that would be great. Thank you.
Okay. I was like, share away, Ryan.
Okay. And I will drop the link for all of these resources in the chat. But if you would like to access more free resources, especially for math classrooms, please check out our back to school free resource toolkit at amplify.com/mathbts toolkit. That also includes the instructional cards support cards that Kristen mentioned throughout this webinar. So feel free to download that to access those support cards and as well as some other incredible great math resources. I know that it's geared towards back to school, but there are resources that you can use in your classroom all year round. So feel free to go ahead and access that. Um, don't hesitate to sign up for more of our math webinars. We have some really great fall thought leadership coming up this season. You can register for that at amplify.com/math webinars. And if you are a K-5 teacher or a teacher of multiple subjects, we do have a math symposium coming up next week on September 18th, where we will be talking about how to improve science instruction and engage all learners. The link to register for that is amplify.com/2024 Science Symposium. We have some incredible speakers lined up for that, including the Science All-Star Hank Green. So we'd love all of you to join us for that as well. With that being said, I think that we are good to go, unless you had anything else to share, Kristen.
Nope, I think that is great. I just want to say thank you. All the participation in the chat was so wonderful. Just really appreciate all of you for coming.
Thank you so much, everyone. Have a great rest of your evening.
Thanks.